day-by-day breakdown of Deepseek's OSS week, where they literally released open source projects every single day of the week, except on day 7. This is going to go deeper into the stack than usual because I don't usually go into the AI infrastructure stuff, but I made an exception this time because seeing companies open source the building blocks they use to build these LLMs is really cool. Sorry for the stuffy nose. Let's dive in. Day 1, FlashMLA. This basically runs AI models more efficiently on Nvidia Hopper GPUs. Specifically, it focuses on the decoding part of multi-latent attention, or MLA, which is in the name. Basically, when you have an LLM, the LLM has to do a bunch of math to figure out which token to output next. In that process, it stores key values in something called a key value cache. From this cache, it needs to decode the keys so that it can calculate what to pay attention to, and that is then used to figure out what the output should be. Multi-latent attention is basically a way to store that key value cache in a more efficient way. So essentially, this project makes it more efficient to decode multi-latent attention key value caches into outputs. Day 2, DeepEP. This is a communication framework that speeds up MOE, or Mixture of Experts. Mixture of Experts is a new-ish adjustment to transformer architecture, where essentially you split up the internals of the transformer into multiple experts. These experts can work in parallel, and then there's this gating mechanism that figures out which experts should be activated. So you need a lot of servers to do this because the experts might be distributed across different servers. You might have GPUs that need to talk to other GPUs on the same server via an NV link, or you might need RDMA to talk between servers, and DeepEP essentially just optimizes this communication. Day 3, DeepGEMM. This is a library that makes FP8 general matrix multiplication more efficient. FP8 stands for 8-bit floating point. Basically, LLMs do a lot of matrix multiplication, so when you took linear algebra, there was a reason. And this library just makes it more efficient to do this kind of matrix math. Day 4, this was actually the release that I thought was most interesting. They released a couple different libraries related to the computation-communication overlap. So this project called DualPipe helps make parallel training more efficient. Basically, when an LLM is really big, you have to split it up, and you have to distribute that work across multiple machines, which also means you have to communicate with each machine and send data back and forth. The problem is when you do this, you'll probably introduce inefficiencies called pipeline bubbles. This is essentially when a GPU isn't actually working, it's idle because it's waiting for data. So DualPipe essentially fetches the data that the GPU needs while the GPU is working on the last batch of data. And this results in a full overlap of forward and backward communication phases, so that you have fewer GPUs idle. Day 5, finally, some file system optimizations. Fireflyer file system, or 3FS, is basically a distributed file system. And again, you need this because when you have to train a really large LLM, you need multiple GPUs, multiple servers, and you have to store the data across multiple machines. That was a lot. Do you even need to know all of this? Probably not. But for those of you who watched to the end, thank you. I'm Diana, and I break down tech startups and AI without the hype. Follow for more.